Joining us, we have Guy Newsham. He is with NRC, and he'll be just talking to us about intelligent buildings. NRC Construction is working with its federal partners to implement smart building approaches into building portfolios. Results to date have been impressive, with fault detection associated with an average of 7% energy savings and short paybacks in large office buildings. They are now extending these benefits to smaller commercial buildings. Low-cost occupancy detection is also a route to HVAC energy savings, and may now also support a safe return to work during the pandemic. Guy Newsham has a PhD in building science from the University of Cambridge and now leads the building technology optimization team at NRC. He has led projects on post-occupancy performance of green buildings, sensor networks, smart meter data analytics, demand response, office equipment energy use, office environments and organizational productivity, lighting quality and control, and thermal comfort. He has more than 100 technical publications on his work, which have received numerous international awards, and he's been a thesis examiner in Canada, Sweden, France, Denmark, and Ireland. Wow, Guy, that is a pretty impressive resume there. Thank you so much for joining us today.
My pleasure. I've just unmuted. Just want to confirm that you can hear me.
Loud and clear. And am I pronouncing your first name? Is it Guy or Guy?
It's Guy. Thank you for getting it right and asking. Yes, I often get Guy in Canada, but it's actually Guy in my case.
All right. Well, I think it was a lucky attempt at me today, so I'm glad I got it. And the mic is yours. Thank you again.
Thank you. Thank you. And the photograph that you just saw of me on the agenda there, that's pre-COVID. I'll let you know that entropy has set in. So fortunately, you can't see me this morning. You can only hear me. So let's move back to the slides. So I guess I'm going to prompt you to move them forward when I'm ready. Is that correct?
Yeah, that's correct. You can say next slide. Okay,
I don't need to share my screen. I'll just prompt you. Thank you. Thanks, Greg. Yeah, so I'm going to talk a bit about the smart buildings work that we've been doing here at NRC Construction and a bunch of alphabet soup that goes along with that. I'll touch on each of these different acronyms as we go through this presentation. Next slide, please, Greg. So I'll talk first of all about some of the work we've been doing on relatively large commercial buildings with the rest of the government of Canada. And first of all, I should say that when we talk about smart buildings in this context, it's a very specific meaning of what smart buildings is. Smart buildings, of course, is a broad universe. In this case, we're talking about, for now, to begin with, building energy management systems, BEMS, which, for those who don't know, is essentially software that sits on top of the regular BAS system, collects data from the BAS points, which can be thousands of data points every 5 minutes in a large commercial building, temperatures, flow rates, CO2 levels, etc., and analyzes those data and looks for evidence that certain things aren't being done in an optimal way, fault detection in the broader sense. And then creates flags for building operators to go and investigate those issues to see if there's anything that can be fixed and the building can be tuned up. So there's lots of commercial off-the-shelf software providers for this technology, and that's what we've been working with, as you'll see. This began back in 2014 when it wasn't such a common approach with a single building in the PSPC portfolio, a pilot project, which I'll refer to later as Building J, since we're not identifying buildings. That went pretty well, and the pilot got expanded to 4 buildings, 9 buildings, 13 buildings, 20 buildings, kept on going well, and in the end, PSPC decided that this was appropriate for a national master standing offer, which means it applies then for a larger portfolio of office buildings, and it's now this technology is now in place in more than 100 PSPC office buildings across the country. So that's been quite successful in terms of scale up. That got the attention of D&D, who operate their own portfolio of buildings on the various defense bases across the country. In this case, thousands of buildings, some large buildings and then some smaller commercial buildings that don't have building automation systems. That work is still sort of ramping up. We're getting some early data back from those bases, but that's expanding as we go. And we've also engaged with Canada Nuclear Labs and their main campus at Chalk River, which is undergoing a major renovation, and this smart buildings approach is part of that exercise as well. So it's been getting a lot of traction. And what's been attracting all of these people to it is the data we're getting from PSPC, which is showing now over multiple years an average of about 7.5% annual energy savings in these large buildings. And because this is primarily software and relatively low-cost fixes of faults that are detected, it's often a question of just changing schedules or set points or fixing a damper that's stuck or whatever. The paybacks are very short. I mean, I say 1 to 2 years. In many cases, it's a matter of months as payback on these systems. So for building operators who are faced with the challenge of meeting various targets that they've been given, this is a relatively quick win that they can get as a stepping stone to deeper savings in the future. Next slide, please. So with PSPC, what we've been doing more specifically is that say they've got many buildings. They of course got many different building automation systems from many different vendors. They have multiple BEMS software suppliers from multiple vendors. The government doesn't tend to want to go to single suppliers. So what we're doing for them is that we're tying all of that data back together into a single unified database. And that enables us to provide them with various portfolio level dashboarding services. You see on the picture on the sort of to the left in the middle with all the red bars on it, various dashboarding, standard dashboarding approaches across the whole portfolio, and then tying data together from electricity meters, gas meters, steam meters, as well as the building automation system data. We can also push data out into lobby displays in individual buildings. So you can see building J there and one version of a lobby display we were doing in that case. And then it also gives us access to the data to do some other, what I'll call for now, remote auditing functions. And I'll talk a bit more about that in the future. So that's the sort of the EMIS, the Energy Management Information System that we're providing on top of all of this for PSPC. Next slide, please. So another function that we're providing for PSPC is to give them some kind of independent measurement and verification of these systems once they're in place. So there's a real challenge, as many of you probably know, when it comes to M&V in this kind of context, and I've tried to lay it out here schematically. So you might look at energy use, total energy use for a building over time, and you implement an energy saving measure. And what you'd hope to see is a nice simple step function where energy use goes down overnight once you've installed the new technology, whatever it is, and you can easily measure that step function difference. And if you were doing an LED lighting retrofit across the whole building within a matter of a couple of days, this is exactly what you might expect to see, especially if you were looking at electricity separately. But in the context of this sort of fault detection approach, it's much more complex than that. So if you just click the space bar or something, Greg, it should produce a little bit of animation. Yes, so there's various things here that make it more complicated. So one is a transition period. So we have evidence from the field that building operators, in anticipation of the software being installed, will start to look a bit more carefully anyway what they're doing, and there could be some savings actually before the implementation date. And then the nature of this approach is that faults are detected, this information is pushed back to operators. They don't necessarily act on it instantaneously. Faults appear over time, and therefore you don't get this step function. You tend to get this, this gradual decline over a period, this slope, which is harder to detect. Next. Then we have additional energy conservation measures that are applied in these buildings, and PSPC, in particular, is a large organization with many fingers in the pie. We don't necessarily know what all those fingers are doing. And so it's certainly possible that other energy conservation measures are happening simultaneously that we don't know about, that aren't registered anywhere centrally, that also complicate matters. And then next, Greg.
And you may want to define PSPC for some of the, we have a lot of Americans on the phone that may not know, and even some of the other government departments, even D&D, may not be as common knowledge.
Okay, Public Services and Procurement Canada, who are among several functions, they are the federal landlord. So GSA would be the equivalent organization in the US. Thanks, Greg, for that, asking for that.
One other note, Guy, while you're, since you've been interrupted, if anyone has questions, you can type them down into the Q&A box, not the chat box, the Q&A box. I'll be watching that, and if it's a relevant question to right where we are, I'll interrupt Guy and ask the question. If not, we'll get to the questions at the end of the presentation. So okay. Please don't hesitate to put your questions in.
Thanks. So yes, so PSPC has the job of providing accommodation for all the other federal departments. There's a few exceptions, DND is one, but in general, all the other federal departments are provided with accommodation by PSPC in both Crown-owned and leased buildings, but PSPC manages the whole portfolio. So then, as you can see, on top of that, we have weather effects, which also are a common complication in M&V. And then finally, one more press there, we'll see there's a whole bunch of other things that can go on that aren't necessarily recorded, changes in tenancy or occupancy, the operator themselves changes and a different person comes in and behaves differently. There's a whole bunch of complications. It's really challenging. So how do we address that? Well, there are some industry protocols for doing this. The IPMPV protocols are some of the most common. So if you go to the next slide, Greg, this is generally how it's done. You look at, this is again building J as an example, and here in this case we have monthly data, and I think I'm showing chilled water as an example. You've got a baseline period of monthly data before in this case, the software is installed, and then a reporting period after the software is installed. So if you look at the monthly data before the installation, the real data is in red, and you create some kind of equation that predicts what that would be. In this case, it's a fairly straightforward multiple regression equation that looks at weather, heating degree days and cooling degree days. It looks at number of working days in a month, and creates an equation that predicts what energy consumption is based on those things. And you can see that on the left in the baseline period, you've got a pretty good match between the red actual and the blue prediction. And then you take that blue prediction and you move it forward into the period after the software is installed. So again, you have the weather data, you have the working day data, and absent any change, the blue line would then predict what expected energy consumption would be. The red line is the actual, and the difference between those two are your energy savings. That's kind of how it's done. It's relatively straightforward. There's all kinds of different nuances to that, but that's generally how it's approached in this context. So next slide, please. So here we have data from 31 of those large PSPC office buildings, for which we have enough data over the long term. So this is at least 3 years worth of data from these buildings. So you can't measure your effects within a month of installing the software. You need a lot of time to try and tease out all these effects. So in this case, we've got at least 3 years of data for 31 buildings. And here I've just listed the savings that we see, annual savings to date, by building, rank ordered from best to worst. And you can certainly see that there's a big variation in what happens in these buildings for all kinds of reasons that I might have intimated earlier. And in fact, there are some buildings that show higher energy use after installation of BEMS than before. And you can imagine a variety of reasons why that might be, as I've just described. So the key thing here, I think, to look at is it's quite difficult in this context to look at individual buildings and necessarily attribute success. But if you look across a portfolio, you can start to see something that's quite reliable and comes through. And you can certainly see that for the vast majority of buildings, we're seeing savings. And as I said earlier, the median is 7.5%. So across a portfolio, that's pretty substantial. And I've highlighted building J here again in the distribution. And this is kind of a happy accident, I suppose, in a way, but it's nice to see. Building J, the very first building we started with, for which we now have 6 years of data, it turns out it's not a particularly unusual building in this context. It's kind of in the middle of the distribution. It wasn't as if we based this whole program on one very unusual high energy saving building. It's sitting there quite nicely in the middle as a pretty average example. So that's kind of a nice check that we were doing things in a sensible way.